Welcome back. We're going to be going over U substitution by integration. But first, let's look at where did we get this from. So first, we're getting it from the chain rule. And so all U substitution integration is the reverse chain rule. So let's start off with looking at the chain rule, finding the derivative of cosine 5x. Well, you see that we're going to have to find a U, which we're going to say is our 5x. Okay, the derivative of that is going to be 5. So we take the derivative of the inside times the derivative of the outside. So the outside is just going to be this main function cosine u. The derivative of that is literally going to be negative sine u. So all we got to do is take the derivative of the inside times the derivative of the outside. Okay, so we have 5 times the derivative of the outside. Cool. So what does that give us? So we have negative 5 sine of 5x. Cool, not too bad. So if we take the antiderivative of this, we should get back to where we started. So when you have U substitution, what you want to do is either look for things that you can take the derivative of and then the derivative is there, or what I like to do is just look at what is the craziest, what is the hardest thing that's there. So if we look here, the craziest thing going on is probably that 5x. So we're going to go and we're going to look at this 5x here. That's going to be our u. So we're going to take the derivative du over dx. So the derivative of u with respect to x. So that's going to be 5. But here, we're going to times both sides here by dx because we need to have our dx here. So this is just going to be 5 dx. So now when we rewrite this, we can see this here and we can begin to kind of move some things around. All right. So what I'm going to do is we're going to put this negative here. We're going to have our sign here, and I'm just moving this 5 dx over here. So you can see that that 5 dx, that's our du, and this is going to be our sine of u. Okay, so when we go and we say the integral of sine of u du, cool. So we take the antiderivative of that, and we can see that's going to be negative times negative cosine u plus some c. Negative and a negative is a positive. Substitute back the u in there. This is my final answer. So let's see, is that where we came from? Yes, that's where we came from. Cool. So let's look here. So things look kind of crazy. You can look for that derivative here. You can see that 2x. We always want to pick a u. So we're going to pick our u. It's going to be 1 plus x squared. Okay. Well, we're going to take the derivative of that, and that's going to be 2x. Okay. We're going to multiply both sides by dx. So the dx is coming off the bottom, or the denominator. This is going to be 2x dx. Like I said here. So let's move some things around. So I have 1 over this here times 2x dx. All right, so hopefully you see here, this is my du. And hopefully you see this is my 1 over u there. So now I can write a new integral, 1 over u du. Okay, well, what's 1 over u? That is going to be natural log. So ln of u, the absolute value plus some constant. So I'm having the absolute value of what was my u? This here. So my question is, how do I know if that's right? Yes, I'm going to take the derivative and I should get back where I started. Okay, so I want you to try this one on your own. Okay, just pause the video, try it, and come back. Okay, I'm glad that you tried it. Obviously, you need a U. You should have used that 100x. du over dx is going to simply be 100. This is a little bit trickier too. This was a more advanced level 2 problem. So here we have 100 dx. But I only have dx, I don't see 100 dx. So in this case, what we're going to do is divide both sides by 100 and make du over 100 equals dx. So we can kind of match some things. So when we come here, we're going to have our integral here times dx. So wherever I have dx, I'm going to have a du over 100. Okay, and this is going to be e to the u. All right, so I'm going to have e to the u times du over 100. Okay, well, I'm told that I can put my constants on the outside, which is just going to be 1 over 100 du, eu times du. And that's simply going to be 100 times e to the u, which is just going to be 100 times e to the 100x plus c. Okay, you could put it all over that 100, but that's what you have right there. Thank you and have a good day.